Ruler cannon. So I looked up the example experiment video and I saw that there's some bending going on, there's some deflection going on with the rulers, and I think that might be the case that affects the velocity of the ball. And also there's like this strange thing that the ball suddenly gained kinetic energy to be able to travel with a velocity, and that might be because the energy is being transferred from the rulers to the ball. So there might be some energy stored inside of the rulers before. So at first we are going to try to find the area moment of inertia of the rulers by measuring the height or the thickness and the width of the rulers. Then finding it with this equation over here. Then we're going to try to find the Young modulus value, and by conducting a small experiment I am going to find a fixed end for the rulers, and then I'm going to measure the length, the actual length of the rulers, and then going to take a video of adding coins or load to the rulers, and then I'm going to measure the length from the video based on the video, and then also measure the deflection or the y max value from the video, and then I'm going to be able to find the actual y max value from the ratio over here, and then from this y max value we are going to be able to find the Young modulus value. Then here are some values I found. It kind of matches the material property chart over here, and after that we are going to find the normal forces of the ball. While we are like inserting the ball between the rulers, there must be some normal forces acting on the rulers, and so these forces can be looked at as loads for the beam. So like there might be something to do with deflection again. So we are going to use the same formula, the deflection formula, to find n this time by measuring the y max and substituting the values of these three variables that we already know. Then we are going to be able to find the strain energy stored inside of the rulers, because there's load and there's stress, and so there's strain because like there's deformation of the rulers, and so there's strain energy inside of the rulers, and the strain energy can be found using this equation, and that force is basically the end force that we just found. And so we got the U value or the strain energy value, but then the strain energy value will be 0 again once the ball is being ejected, which means that the strain energy is being transferred to the ball into kinetic energy for the ball to be able to travel with speed. And this is caused because of the work done by us, or we are the one that causes the external work done. So it's going to change from strain energy to kinetic energy. And from this conservation of energy equation, we are able to find the initial velocity of the ball. Then in conclusion, that the parameters that affect the velocity of the ball is basically first thickness, width, and length, which affect the area moment of inertia of the rulers, and that area moment can affect the E value or the Young modulus value, along with the type of materials that the rulers are made of, and these two are going to affect the U or the strain energy value of the rulers, which can cause the difference in the velocity value. And then there's also an effect from the work done applied while ejecting that can cause the velocity to increase or decrease. And there's the mass of the ball or the object that is included, because if the mass is too much, it's going to cause the velocity to decrease.